Hey, everybody. Hopefully, you're having a fantastic, wonderful Wednesday. We're going to go ahead and get started with what we did today in class for those of us who didn't attend or just need to go through and answer our 3-question Google form. So, yesterday we started our topic of brain structure and function, and today we're going to be going into it a little bit. We talked about it in class. There will be a project we're going to talk about like when we get back to school. And this is just an introduction. So, like, I'm not expecting you to fully understand and know all the different parts of the brain and what they do, but this is just an introduction to all those different parts and what they do within your body. So, we're going to first start off with this video as our phenomena. It is an interesting video because it takes a good look at the different parts of the brain and what they are in charge of, as well as some diseases that can impact brain and brain function.
So, how did it get to be this way?
Well, it's my professional opinion that the large gaping bite mark on its shoulder might have something to do with it.
Thanks. I mean, what causes its behavioral abnormalities?
Well, we know all behaviors are rooted in the brain, so I'd expect that something's gone terribly wrong, probably in there.
Thanks again, Dr. Obvious. Let me be more specific. What changes in the brain would have to occur in order to cause this kind of behavior?
Well, let's see. The first thing I notice is how it moves. Stiff-legged, with long, lumbering steps, very slow and awkward. Almost like what you'd see in Parkinson's disease. Maybe something's wrong with its basal ganglia? Those are a collection of deep brain regions that regulate movement through a neurochemical called dopamine. Although most people think of dopamine as the happy chemical of the brain, the dopamine-containing neurons in the basal ganglia die off in Parkinson's disease. That's what causes it. Makes it more and more difficult to initiate actions.
What? Look again at how it moves. Stiff legs, long stance. These aren't Parkinsonian movements. Parkinson's patients take short, shuffling steps. And the posture's all wrong. This looks to me like what happens when the cerebellum's damaged. The cerebellum's a little cauliflower-shaped area in the back of your head. But don't let its size fool you. That little guy contains almost half of the neurons in the entire brain. Patients who suffer degeneration from this region, something called spinocerebellar ataxia, show a lack of coordination that results in stiff legs, wide stance, and a lumbering walk. My money's on the cerebellum.
Touche. Okay, so we've nailed its motor problems. Now what about that whole groaning, lack of talking thing?
You know, it sounds kind of like expressive aphasia, or Broca's aphasia, which makes producing words difficult. This is caused by damage to the inferior frontal gyrus, or possibly the anterior insula, both regions behind your temple on the left side of your head.
I think you're only half right. Zombies definitely can't communicate, that's for sure. But they don't seem to do a good job of understanding things either. Watch this. Hey, Walker, your father smelled of elderberries. See? No reaction. Either it's not a Monty Python fan, or it can't understand me. I'd say this is like spot-on fluent or Wernicke's aphasia. Damage to an area at the junction of two of the brain's lobes, temporal and parietal, typically on the left side of the brain, is the culprit. This area is physically connected to Broca's area that you mentioned by a massive bundle of neural fibers called the arcuate fasciculus. I hypothesize that this massive bundle of connections is completely wiped out in the zombie. It would be like taking out the superhighway between two cities. One city that manufactures a product and the other that ships it out to the rest of the world. Without that highway, the product distribution just shuts down.
So, basically it's a moot point to reason with the zombie, since they can't understand you, let alone talk back.
I mean, you could try, man, but I'm going to stay on this side of the class.
Like I said, I don't expect you to know all of the terms, the medical terms that they use, but it was a very good video just explaining the different parts of the brain and what they're in charge of. And today we're going to be looking at sections of the brain as well as what they do for your body and you as an individual. So, the brain. It is the most complex part of the human body. It is the head of intelligence. It controls your behavior, initiates body movement, and interprets senses. The brain is like a committee of experts. All parts of the brain work together, but each part has its own special properties. The brain can be divided into 3 basic units: the forebrain, the midbrain, and the hindbrain. When we're talking about the brain, it's a lot like our levels of complexity, because within your brain, that's the whole overall system. There are subsystems. So like the forebrain, midbrain, and hindbrain. And within those 3 different sections of the brain, there are also different pieces within. So the hindbrain. The hindbrain includes the upper part of the spinal cord and the brain stem. A wrinkled ball of tissue in there is also known as the cerebellum, or cerebellum. The hindbrain controls the body's vital functions such as breathing and heart rate. That is a question off of our 3-question Google form for today. So the hindbrain controls the body's vital functions such as breathing and heart rate. The cerebellum coordinates the movements and is involved in learning habitual movements. So, like things when you're playing an instrument or hitting the gaga ball at recess, you're activating your cerebellum. Part 2 of the brain is the midbrain. The midbrain is the uppermost part of the brainstem. It controls some reflex actions and is part of a central nervous system. The midbrain has a role in hearing, sleep and wake cycle, alertness, temperature regulation, eye control, and other voluntary movements. And the forebrain. The forebrain is the largest and the most highly developed part of the human brain. So this is the second question off of your Google form. So that the forebrain is the largest and most highly developed part of the human brain. It consists of primary of this cerebrum, and the structure is hidden beneath it. When people see a picture of the brain, they usually see the cerebrum. That they notice it sits at the uppermost part of the brain and is the source of intellectual activities. It holds your memory, allows you to plan, enables you to imagine and think, helps you recognize friends, read, and play games. And like we said, this is in your Google form for today. Which part of the brain is the largest and most highly developed part of the brain? That is the forebrain. Cerebrum. The cerebrum is split into 2 halves called hemispheres. So your big old brain, your whole brain, so every part we're going to talk about today, there is a line right down the middle, so starting there all the way down, that separates your brain out into 2 hemispheres. So for some reason, most signals from the brain and body and vice versa, so from body to brain, cross over on their way to and from the brain. This means that the right cerebral hemisphere primarily controls the left side of the body, and the left hemisphere primarily controls the right side of your body. So whatever side of the brain it is responding for the opposite side of your body. So left side of your brain responds to right side of body, right side of the brain responds to left side of your body. Meaning, so if you have a stroke on the right hemisphere of the brain, it can leave your left arm and leg paralyzed. Now we get into lobes. So if we're looking at it, the first is the frontal lobe. The frontal lobe, keep in mind you have 1 in each hemisphere. The frontal lobe plays a vital role in memory, emotions, and decision making, and your personality. There was a rare case, a really interesting case, where a railroad worker accidentally got a railroad spike that went into his frontal lobe, and it actually completely changed his personality. So when you plan a schedule, imagine future events, or use reasoned arguments in these two lobes do most of the work. One way the frontal lobe seems to do these things is by acting as a short-term storage site, allowing one idea to be kept in mind while other ideas are considered. In the rearmost portion of your frontal lobe, is the motor area, which helps control voluntary movement. A nearby place on the frontal lobe is called the bronchius area, which allows thought to transform into words. The parietal lobe, you have 1 in each hemisphere. They lie directly behind the frontal lobes. It's kind of at the top of your head if we're looking at the picture. When you enjoy a good meal, so like the taste of it, the aroma, the texture of the food, the parietal lobe is at work. The forward parts of these lobes, just behind the motor areas, are the primary sensory areas. These areas receive information about temperature, taste, touch, and movement from the rest of the body. Reading and arithmetic are also functions of each of the parietal lobes. And the last one we're going to talk about today. As you look at the words and pictures on this page, 2 areas in the back of the brain are at work. Our occipital lobes. They process images from the eyes and link that information to images stored in memory. So for example, I'm looking at and holding a black pen in my hand. Looking using this occipital lobe, I can see, all right, it is small. It is about, 3-4 inches. It is black at the main part and gray on the front end and the back end. Using my occipital lobe, I'm able to use the images that I've stored in my memory to say, oh, this is a pen. So the occipital lobe's primary responsibility for processing stimulus and visual stimuli. So damage to the occipital lobes can cause blindness. And the last thing I will say when we were talking about the wonderful Google form is I put a goofy question at the end. It was just to try to keep things interesting. Looking at that goofy question, all you really have to do is type it into Google. It's come to my attention that it says 91.578 on the thing. This is the closest answer, so that will be what you're going to put in there. Have a wonderful day. I will see you tomorrow. Bye.